Hello and welcome back to another video. In this problem, we are asked if x is greater than 0 and a is greater than 1, then is the natural log of x over the natural log of a equal to the natural log of x over a. So to show that this is true, what we're going to do is we're going to turn these into exponentials, where we say, okay, ln, of course, is log base e. And let's say that log base e of x equals y, and log base e of a equals z. So here, of course, ln of x is y, over ln of a is z. So the problem is that we have to prove that ln of x over a is equal to y over z. So this is, of course, log base e of x over a. And let's just say that this is equal to some value w, where, separating it just to this, we can see that this is e to the w is equal to x over a. How do we find what w is? Well, we know that x is equal to e to the y. How do we know that? Because we can rearrange this logarithm to get e to the y equals x, and also e to the z equals a. So e to the w is equal to x over a, which is e to the y over e to the z. Therefore, we can say that e to the w is equal to e to the y minus z. And if e to the w equals e to the y minus z, then w equals y minus z. Therefore, log base e of x over a, or ln of x over a, as the problem puts it, is equal to w minus z, which is log base e of x, ln of x, minus ln of a. And therefore it looks like this is not true, because here we have division, here we have subtraction. However, using the properties of logs, if we are subtracting one log from another and they have the same base, they are equal to the singular log where one is divided by another. Therefore, ln of x or ln of a is equal to ln of x over a.